Sir, please start.
Okay. Welcome you all. Good morning to you. And I understand the attendance is poor, but you can have the leisure of the videos online. It would be given to you later. First of all, this is my third session, and to cover a little bit remaining issues of the day 3 and day 4 as well. But there has been a little change during the period, and today you have a session, a grooming session, starting from 1 o'clock. So naturally, I have to truncate a little bit of that because that is very important issue after the situation after your course is over. You have to apply for jobs and etc etc. So these grooming sessions are very important, and the institute has a beautiful placement cell which takes care of you people if you are of course employable. So that is a part of the whole curriculum, that to make you employable, and then the institute will facilitate all you people who are interested and are employable. So please attend the grooming session, which will start at 1 o'clock. Please attend that. And so what I have planned is that I have, as usual, two very comprehensive documents with me. The number one is what I am presenting, the spillover from the previous day regarding unit 3. I will have 1 hour, basically speaking. So what I have done is that what I have planned is that the first half an hour, maybe I will, just tell you about what is there in unit 3 and some of the issues which you must, as a final student, now it is a time for you to expand your horizon and be able to develop. It is not only about solving sums and getting through the examinations, it is also about your placements, which institute takes pride to present you with. First of all, I would, the first half, maybe after 12:30, I would have to be very particular, talk about the issues which are left out in unit 3. And again, I have a very comprehensive document, and I'll present that. And in unit 4, again, I have a 25-page document which I will share with you. But I'll just say what is there. So half an hour is too little a time to talk about all the issues there. So I will just talk about some of the issues which I feel is very important, because it's a very important, very interesting module you have, unit 3, which comprises of it is all about risk, and the risk, connotation of the risk, the understanding of risk, the sources of risk, etc etc. So that I will start from 11:30 till 12 o'clock. I will continue with that. So please attend the 1 o'clock grooming session, which is very important for you, because you have to apply for jobs after the course is over. You are almost at the end of it. And this is this. And let me start, because I have just half an hour to talk about some of the issues of the previous day. Now this is about unit 3, and there are some issues which I couldn't cover up because of a shortage of time. And again, I have a very comprehensive document of the issues I'm talking about right now. Now the and this is coming. This is really coming in 2 marks, 7 marks, 3 marks, etc etc. As you will show, because I have as you will see, because I have included some of the questions from various question years into my document as and when required, as and when you can see this. Well, uh, I will exactly go to the issues I'm going to talk about today. So I'm going to talk about this mathematical aspect of this module, where we talk about the differentiation. So we'll be talking about the differentiation, why we differentiate, and what do we get out of it. Now the point is that first of all, you need to understand that in cost accounting, our curves are really straight. So we assume that per unit cost remains same. So we will have a curve like y is equal to mx plus c, where c is the fixed cost, and M, the slope of the curve, is the variable cost per unit. So in cost accounting, generally you have a straight line curve which starts from over here, where this is the y-intercept. So this is the y-intercept, and this is the slope of the curve. So this is the M and this is the C. So you have this fixed cost and variable cost per unit. This is the general parlance, and of course there is a step up of situations where variable cost, fixed cost changes. You have to, so that is you must have done that quite well in your relevant costing. But in economics, the situation is not like that, or in a practical scenario, the situation is not like that, as is assumed in cost accounting for simplicity's sake, for understanding sake. Maybe for a very short run, this remains the same, but in general, doesn't happen that. In economics, you have cost curves which are, like this, mm, uh, so basically speaking, the variable cost curve and the fixed cost curves are, sloped. So you have a positive slope or a negative slope. That means as you go on producing, so this is you go on producing, your total cost or your total revenue for that matter are sloped. So you basically have the x function is squared. So you have squared or cubed function. So your total cost function may be your total cost function economic experiments maybe twice x squared plus 3x plus 5. This may be this may be a situation, but point is that you have a total cost curve which is not the usual way which is assumed in the cost accounting, where the M is the slope of the curve, and as simple as that. So what you have to do is that basically here also you might be required to calculate the marginal cost. So here also you might be required to calculate the marginal cost, or the average cost, or for that matter, marginal revenue, or total revenue for that matter. So, total cost, total revenue. So for this purpose, we use the concept of derivatives or differentiation. So in this document, you will find the rules of differentiation, which I have included just for for your. You just need to gather up those issues which you have done very previously. So the main one of the two issues be careful of, that is the derivative of a constant is 0. And when you do this with respect to x, you write it in this fashion. And the derivative of dx of x to the power 2 is equal x to the power n is equal to n x to the power n minus 1. So this is the basic concept which we'll be using again and again. And there is also another one. So d dx of constant into x is equal to the constant itself. So these are the three important rules in addition to the usual rules which we have. So for example, the total revenue curve is given as the total revenue curve is given as the price into quantity. Total price into total quantity sold is the total revenue curve. So you can differentiate the total revenue curve. You have to do this to calculate a Q in the quantity is taken in terms of Q or in terms of X, as the case may be. So this will give you marginal revenue. And similarly, if you take the differentiation of the cost curve, this will give you marginal cost, that is cost of one additional unit. So this concept is to be used here in details, and that is one of the very important issues which are coming regularly in the examination. This is from a very interesting Swarm series book where you find So here, basically speaking, f dash x is the first order derivative, is the first order derivative. Be careful about that. And f double dash x is the second order derivative. So here you find the slope of the function, which you take the first order derivative of the curve. This is the curve. This is the curve, and this is you know, the first order derivative is positive. So as you see, it is, the slope is increasing. Here the slope is negative, so the first order derivative f dash x is negative. So like this, uh, you might also require to calculate, this is the second order derivative, which shows that this is an increasing function. This is an increasing function. So if you see, the function is, you know, increasing, and this is a decreasing function. So this is a very interesting concept. This is a very interesting document which is surely going to help you. And here also you have the slopes are negative. So the slopes are negative. Slopes or first order derivative is negative, and this is a decreasing function. Sorry, this is an increasing function, and this is here the slope is negative, and it is a decreasing function. So now the question comes, because the cost curves, you know, are, you know, it's like the cost curve is generally like this, where it falls in the niche. This is a cost curve. This is a cost curve which falls. This is total cost and quantity. So the cost falls in the beginning and then rises. So you have a point which is, you know, which is the minimum. So we would like to calculate that minimum point. These points are called critical points, where the shape of the curve changes. So these are called, sorry, critical points. So these are called critical points where the shape of the curve changes. So what we do is that we, this is called the relative minima or relative maximum. This is a relative minima, because, you know, the curve touches the minimum point and then goes up. The opposite can also be true, where if the total revenue curve is like this, this is relative maxima. This point is the relative maxima, where the point touches maximum and then falls. So that point, these points are called, critical points, which we got to understand. And so for that, what we do, we basically, you know, calculate, we set. So what we do, we set the first order derivative. We set the first order derivative equals to 0. So this is condition 1. Why? Because, you know, if the first order condition is 0, then you get the critical point. So you get a point out here where the first order derivative is 0. Or the slope of the line. This is nothing but, we can call this the slope of the line. Okay. So we call this the slope of the line. Slope of the curve is 0. So so this is the first condition. And number 2, for to understand understand the maximum or minimum point, we have to do second order derivative. Sorry, very sorry. And second order derivative. So I know that you are proficient with that with 1 month to the examination. I know that you are proficient with that, but still, that is why, you know, I prepared this document for you. It might be of help to you. So if it is if it is positive, so this is positive. That means the curve will increase after this. So the curve is, you know, convex. And if it is negative, so this means this is negative. So if the second order derivative is negative, is negative, that means the curve has reached its maximum point and it will come down later. So these two are the simple issues, and be careful about this, because we are going to, if once you understand the whole issue, then the whole set of questions which are coming are easy. Don't try to attempt one question and forget about it. Understand the concepts, and then things would be very easy. There are a number of good books. Swarm series books is very good. Just search for mathematics for economics in the internet and you will get very good books. If you look at the study notes, there are a number of references given. Please look into that. So these are the rules which I was talking about, and these are very important concepts which you surely have done at some point of your time, some part of your educational as you went on journey. And this is the constant rule I was talking about. The function of the first order derivative of the constant is 0. This is a multiple rule. When we multiply two functions, you can take the derivative out of the two functions, and this is a power rule. This is the most. This is going to be used very much. This is going to be used very much. Sum and difference rule, okay, fine. Product rule, quotient rule, etc. Change rule. These three are the most important. These three are the most important. So, for example, if two functions are multiplied, for example, you have. I know, forget about it. I know you understand all these issues. So be careful about this thing. And the first three are mainly important. Maybe the first four. This is also very important. So these are the rules of derivative. Now, when we talk about optimization, we really don't know the function, whether it is a cost function. If it's a cost function, we need to minimize that. If it's a cost function, we need to minimize that. It can also be a revenue function. It can also be a revenue function, which we need to maximize. So we really don't know about this. So when this kind of a sum can come, it means maximization or minimization. We are not sure about the second order derivative, but what we can do is that we can take out the second order derivative and try to do that. So I have solved the sum for you. What I have done, I have taken out the first order derivative and set it to 0. So number one, first order derivative, I have calculated first order derivative, or you can call this dy dx, or you can call this f dash x, whatever you feel like. And then I have set this to 0. So I have set first order derivative to 0. And by doing this, I have calculated the critical points. I have calculated the critical points, which for me has come as 3 and 7. That means the function changes its shape. Maybe reaches its maximum or maybe reaches its minimum at x is equal to 3 or 7. Now, what I've done is that now I have put these values in the original function, which is which is this function. I have put the value and I have calculated, this is the second order derivative. So I have calculated the second order derivative. So I have calculated a second order derivative, which has put in we have calculated the second order derivative. Then I have put the values of 3 and 7 over here, and the second order derivative has come to minus. That means it is a decreasing function or concave to the origin. So it's a maximum function. And the opposite can also happen, where when you put 7 into the function, you get a positive. So this is negative and this is positive. So that means you have reached a minimum point, and after that it will start rising. So the marginal concept, which I have already talked about, you have total revenue. So if you take that derivative of the total revenue curve, you will get the marginal revenue. And if you take total cost and you take the derivative or the total cost function, you get marginal cost. So as simple as that. Why now I'm getting into the economic concepts, because marginal concepts are economic concepts. So why marginal revenue? What does marginal revenue means? One incremental change in revenue, etc., etc. These questions come regularly. If total cost function is this, what is the marginal cost? Fine. If total revenue function is this, what is the marginal revenue? Now, what we do is that if you have calculated the critical points, you can put the value of Q into the function and get the exact marginal cost. What is the marginal revenue given the demand function? Now, demand function is basically, now if you look at the demand curve, which will you see that quantity is measured here and price is measured here. This is only one scenario where you have an opposite relationship, so basically the demand function would be upward sloping, and price is generally the demand function is given as in terms of quantity, because you have to, when you change the function, and then only you can have the in terms of quantity, because this is you have to differentiate this in terms of quantity. So differentiate this in terms of so you have to differentiate in terms of U. So you have the function, then you just change the function into in terms of quantity, and demand function is total revenue is equal to. So you have multiplied that with quantity, because this is the demand function in terms of price, and your price into quantity is your demand, is your total revenue. So this is interesting sum. This question came in the examination. I thought of solving the sum, but I have 11 minutes to talk about this module. So this is a solution which I did, of the question which it came in the examination. This is again, this did come in June 2003. Again, a 2 mark sum. So you have to see not only solve the sum, but you have to give the solution. You have to, because 1 + 1 marks for the right answer and 1 marks for the justification. So this is the marginal concept we do, and profit maximization. If you look at my original document, you will understand how we profit maximize. But economically speaking, these are the two important. This is very important. In economics, these are the two things we have to be very careful about. So MR is equal to MC, and slope of the MR is greater than MC. So here we have basically two ways of going about. One is basically we calculate the profit function. Profit function is basically the total revenue function minus total cost function. So this is one way of doing it, and then you calculate the maximization principle which we talked about. You take the first order derivative of the function, first order derivative of the profit function, and then you take the second order derivative of the profit function and see whether that is less than 0. That means it would be a maximum point. This is one way of doing it, and I have taken one way of doing it. The other is simply this: you take the MR curve, you take the TR curve, you calculate the DTR DQ curve, and that is the marginal revenue. And similarly, you have So this is the marginal revenue, and similarly you have marginal cost curve, and then you take the second things, you calculate the slope of the MR curve. That means you take the second order derivative of the curve of the total revenue function, and you show that the slope is greater than the slope of the MC. So this is, I have taken two sums. This is profit maximization. Same principles hold here also. Same principles discussed above holds here. So number one, what you can do, you can take out the profit function, and as I said, simply do maxima minima, do maxima apply, I'll say apply the principles of maximum. So apply the, sorry. So this is one way of doing it. The other is simply you take out the MR curve. That is the first order derivative of the MR total revenue function. You take out the MC curve, the first order derivative of the cost function, and then you show that the slope of MR, that means you take out the second order derivative of the function, is greater than the slope of MC curve. So look, this is some which is given in the study note. Here we do that first type where we calculate the profit as your cost plus revenue. We get a function and then we apply the principles of. So this is the first way of doing it. We calculate the profit, which is revenue minus cost. We take out a single function and then apply the principles of maximum minimum. And so this, I have solved the sum for you, and also ultimately we put the value of quantity which we have got in the original function, and we calculate the maximum profit. So this is one way of doing. The other is this. So this is the I'll say economic way of doing it. So that would be the mathematical way of doing it, and this is the economic way, where I calculate MR and I calculate MC, and then I calculate and I show that slope of MR is greater than slope of MC. So this is the other way of doing it. I had this space for, I thought that I might be doing this over here, but of course I would, because this, I have solved the sum for you. Okay, the material is self-serving, so it can serve itself, the material. So I thought of doing it, but it is there for you. So this is and this sum came, this kind of a sum came, and this is a very important principle. If your critical so I'll write this for you. If one critical point is negative, then ignore that. Why? Because your quantity cannot be negative, because your Q cannot be negative. Even if it is not given like this, that Q is greater than 0, then also forget about it, don't use it. So again, there is also a sum on price discrimination, and what I do is that you have two demand functions. So as you know that you have two demand functions. So what we do is that we take total revenue minus market. So this is market one, and this is market 2. So you calculate the demand of market 1 and then you calculate separately. So just separately, not a very easy, it's a very easy situation, don't worry about it. So with discrimination, when you are calculating this with discrimination, there will be two situations, and then you can add them up to calculate the total profit. And without discrimination is simple, you just add the two quantities. So it would be Q1 plus Q2 in case of this situation. So in this situation, you just add them up and then you calculate the profit, and you will see that the profit as calculated through price discrimination is better in the previous situation. So again, I have solved the sum for you, and this also sum has come, the cost function. This was in the study notes. This was in the study notes. The cost function again in the study, sorry, in MTPs. This question was in the study notes. Well, did come in the examination, or maybe here. Now I come to a very small, maybe I'll take 5 minutes more. I'll go into the next. Now, be careful about this. Be careful about this. What happens when you have multivariate function? That means you have, when you have a function of this sort. Well, of course, again, go through this, message me if you want to get to my classroom, tell them to, put a message. I'll give you my mail ID as well. So if you require, you can get back to me. So, again, this is the first condition where Zx means simply the first order derivative of the function in respect to x, and Zy is the first order derivative of the function in respect to y. Uh, why you need to understand this? Why you need to, so this is the condition one. Only thing is that you have to do partial derivatives. Why you have to do this? Why? This portion is most probably not covered in your study note, or maybe a little bit of things has been said. Why you have to, because this is not directly there in your study notes. Because there is a question of constraint optimization. So you have, there is a illustration I have illustrated. I think go through this, and if required, get back to me. And why? Because this is there in your study material, in your study note. What happens is that if, for example, you want to, maximize your profit, but there is a constraint, you cannot use more than one, which at this amount of material or this amount of labor or what. So you have constraints. Now, if you have multiple constraints, so if you have multiple constraints, then you have to use graphical LPP or simplex, or whatever you call that, graphical method or simplex or whatever you call that. It cannot be done in the way over here if there is multiple constraint. But if there is one constraint, so if there is more than one constant, you got to go to graphical LPP, have to use. But if it is one constant, then these issues apply, what we are talking about. So what we do is that steps, again, I have so what we do is that this is the objective function. So you have an objective function. For example, you want to maximize your profit. So your xy is the objective function. So you want to maximize or minimize your function, which is fx. And now you have a constant. And the constant is gxy equals to c. This is the constant which is given. So what you do is that you formulate. Now this is the important point. You formulate the Lagrangian function. You formulate the which is nothing but so you look, so the Lagrangian function of x, y, and lambda. So that is a Lagrangian constant you bring in. It's a perspective which you create, because this you have to create. So this you have to create, simple. It's nothing but, and then you can add this or minus this, because it is in your study note, it's given as minus, but preferably in some books it's given this, because both the thing will be same. I'll show you why it is. I will not get the time to show, but this can be plus as well. In some books it's given as plus, and in some books it's minus, but I will prefer this as minus, because in your book it is given as minus, in your study material it is given as minus. So lambda, sorry, gxy minus, now you have sorry. Let us not, it is given in this thing. So you create a Lagrangian function. This is the Lagrangian function, and this can be plus or minus, because in some books it is given, because the meaning would be the same. And then you take the partial derivatives of each of them. and solve for the critical points as you have done previously. Now this test for critical points, if it is a multiple constant with lambda, because there are three unknowns over here, you might be able to, asked to take up the Hessian. Of course, it is also to extent beyond me, because but I tried to grasp a little bit of it. And I think refer to your study note. I think regarding this, refer to your study note, because in no other book it's not given as it's not it's written like you're a commerce student, so it's not like you're a student of mathematics. So same as I think this is the, please look here I have intentionally used plus. This is the same sum. This is a similar sum. This is your objective function. This is your objective function, and this is your single constant as I was talking about. And why we do this? There's interesting sum from this book. This from the Swarm book. Is an interesting situation where this function is increased by 1, so x plus y is equal to 57, and then you can show how the profit goes up. So for 1 unit of profit, how the profit goes up, that is a very interesting situation which might comes up. Again, zx is the first order derivative, zy is the first order partial derivative, and z lambda is a partial derivative with respect to lambda. And you calculate this. So you for that matter, you have to do the second order. So these are the critical points. So this is a critical points. These are the critical points, and so this is basically actually you have to do 3 issues. One is zxx. That means you take the second order derivative of the function with respect, second order partial derivative of the function with respect to x as well. So this is and similarly you can take as the second order derivative of the function with respect. First order derivative is taken with respect to x, y, and second order derivative is also taken with respect to y. So this is straight derivative. Say straight partial derivative. These are straight second order partial derivatives. Sorry. And you will also have this. That means you take the first derivative of the function with respect to x, and then the second order derivative with respect to y. These are cross derivatives. These are cross partial derivatives. These are cross partial derivatives. And then you apply Hessian. I'm not going to get into this, but if you refer to partial the multivariate function, you will have an idea of the bordered Hessian. Look, we do this. We have to calculate this, and then you actually just follow your study notes as regards to this. That is the maximum I can tell you about it. Now this is the model, the model which this is also taken from your study notes, and this is a model which I apply for the second order derivative. Now, economic significance of the Lagrange. Now, the Lagrange multiplier is, it gives you a shadow price. It's idea of, if you want to increase your model, if you constant by 1 unit, what happens, etc., etc. So please go through this. It is already 11:36, and of course the meaning of saddle point, where the test is inconclusive. I think you will find this. Sorry for getting this so quickly. I understand that this is not done, but you cannot help this. We cannot, we have to get into the second portion as well. And sorry, let me try out and see where the second portion is. It is not showing. I'm very sorry for this, that I am being so quick as to this material. I don't have much time, but as I said that my material speaks for themselves. Okay, I take trouble of spending some amount of time because I understand that this communication is a very poor form where you don't have uh, okay, I will just give you my uh, mail ID, so you can mail me, and as well as, this is my phone number if you want to get in touch, because well, now let us come to our module 4, which is the last unit. I don't have much time to talk about this, maybe 10. Now, it's all about risk. I will not say it is about enterprise risk, enterprise risk management. It is about risk, various connotations of risk, and you will find that. So if I was given a situation, I would have said a comprehensive understanding of various aspects of risk. Now, what you must be careful about is that you have to first of all understand. So basically, it is understanding risk, the connotation of risk. So what is risk in financial terms? I'm not talking about finance risk. Of course, both can be used in a similar term. Risk in finance world, uh, and basically speaking, risk is with probability. And in this is the first, this is a very important paper in 1921. It came out in 1921 by Frank Knight, where he differentiated the concept of risk and uncertainty. In module 12, last portion of module, study note 12, that is management accounting, you have a little bit about decision making under uncertainty, where you use the Laplace rule and the Savage and the Hurwitz model, etc., etc., etc. So this paper is easily available in the internet. Who are interested can look into this. This is Frank Knight's understanding of risk, uncertainty, and how profit develops. And one of the very, I'll show you my issue. This is from the book by Frank Knight, and he distinguishes between risk and uncertainty. What he says simply that risk is a situation where you have probability of things. For example, something is happening tomorrow. You have uh, uh, so risk is basically variability. So risk is basically variability. So I'll call this variability with prior knowledge. And prior knowledge is nothing but probability. So basically speaking, when you have probability distribution of your issues, how the future is. For example, I use a simple connotation, like for example, I go to fetch my son from the bus stand, and every day the the school bus is coming. Maybe the mean is 1 o'clock. If you take all the dates, I mean, if you take 10 days, for example, one day it comes at 12:56, one day it comes at 12:57, one day it comes at 11:45, and so on and so forth. Maybe some days it comes at 1:10, etc., etc., etc. So for 10 days we take that and we average that and we calculate the mean time. So that the mean time is basically 1 o'clock. So you have now the probability distribution is how this the variable is showing over the period of time. So with prior knowledge, with probabilistic knowledge. But uncertainty is that you do not have knowledge. You do not have probability. So this is the main crux of the issue. Once you have probability, otherwise you do not have probability. Now the understanding is that why risk, uncertainty, and profit. Why? The point is that it is basically the entrepreneurial skill to deal in situations of uncertainty. Risk anybody can deal in. Well, because you know that you have probability of happening, so you can deal with it. So Frank Knight's main perspective was that entrepreneurship is all about understanding uncertainty and how you can take very appropriate decisions under conditions of uncertainty. So basically speaking, he talks about quantifiable and non-quantifiable risk. So what is non-quantifiable risk? This is your uncertainty. This is your uncertainty. So it's a very interesting paper. Of course, I could only manage to understand a little bit of it. And so I have tried to, put in some issues. So this understanding of this paper is, I think, is very important because this is where all the understanding of risk started. And this understanding, so I will say Frank Knight maybe is the pioneer. I don't know. This is as far as my knowledge goes. In 1925, he started it, and in 1954, you have Harry Markowitz talking much about it. So maybe these two perspectives change the whole arena we look into risk today. And after that, the Sharp, Linton, Mosin. So maybe 1971, I will say, another landmark where the CAPM, the capital asset pricing model, was developed. And of course, there are a number of issues, arbitrage pricing nonsense. Maybe many things happened, but basically speaking, I will say that these are three issues which a student must be very careful about. Number one, number two, and number three. So CAPM is said to be the hero of everything you do. You start with CAPM, and this is a source of risk. I don't know. So you have various kinds of risk, but remember, what is risk? Risk is volatility. Maybe, for example, I teach in a college. I get an average salary, and so the mean is okay, and I do not have much volatility in the amount I get, because every month the salary is there, so you already have. So the best way to calculate the volatility is standard deviation. And another person who is into private tuitions or corporate lecturing, corporate talks, he might be earning very much, but the volatility is huge, because someday he gets huge amount of money by spending a lot of time with the students, with the corporate persons, but it is not a very constant figure. So that is the connotation of volatility. So the sources of risk, and this is again, this question did come, and this is a little confusing. Business risk, of course, external risk and exchange cannot be the answer, because it is taking about financial gearing. So remember that when you take debt, as you go on taking debt, you are getting returns might be higher, where returns might be higher. As if you remember, I talked about the Dupont model. The debt might be, as you go on taking debt, return on equity might be higher, but is your risk is also going up. Be careful about that. And that is a very interesting situation which is happening. If you look at the last portion of this document where we talk about the corporate failures and prediction models, everywhere you find the debt equity ratio, because that is a very important ratio. And basically speaking, financial risk, business risk covers much. It does cover operational risk. It does cover operational risk, and it does cover many kinds of risk. Business risk is a larger connotation. Financial risk are numbers of the. So business risk, I think financial risk would be the better answer because it targets the financial matrices. This is again from your study notes. It's wonderfully stated. Risk is basically systematic. Now, this understanding of systematic risk and non-systematic risk is very important, which is covered up in my study material. Maybe the last few minutes I'll be talking on that. And systematic risk are all that covers the market. So it is it covers every instrument. Because this interest rate is the market interest rate, so it changes and it impacts your shares and bonds and etc. These are unique risk. Liquidity risk of your balance sheet, operational risk of how you manage your operations, credit risk of your instrument. So these are unique risk and are diversifiable. So if you are, if you understand that this and you do not take this, you do not pick this share of this particular company, then it's done. You go away, you do away with this kind of risk. So the next portion is the understanding of diversification. Very important. And that is how I feel. Systematic, this question come, unique risk is also known as non-systematic risk, because systematic risk cannot be unique. It is for the whole thing at large. So this is the relationship of, this is from Prasanna Chandra's book. This is from Prasanna Chandra's book, a wonderfully written book, beautiful book. And you see that the market risk, which is this is the non-diversifiable. This is the non-diversifiable. That means if you buy shares in the Indian market, you have to consider this risk. But these are unique risks. Maybe if you do not consider HDFC shares, do not consider HDFC share, then you do not take unique risk of HDFC. So you do not take the unit risk of HDFC. So in this way, you can, if you can diverse it. So this risk is diversifiable. This risk is diversifiable. This risk is diversifiable. So there is a very interesting sum, and this diversification depends on covariance. So standard deviation is the first measure of risk. First measure of absolute risk. And covariance is, how two securities or multiple securities move together. So how they move together, how security A and security B, they move together. So, covariance is, and of course, when you do covariance, you do correlation. So, covariance and correlation are, related to each other. And this is an absolute measure, and this is a standardized measure. This is a standardized measure. Both means the same thing, but this is a standardized measure. And as you know, so this is the formula of covariance. This is a formula of correlation. And as you know that the correlation of x of sorry. So as you know, the correlation of two securities A and B shall be equal to -1, shall be equal to +1. So this is a big advantage over your covariance, where you don't understand the meaning of covariance. But both means the same thing. How two shares are moving together, how two shares, two securities, two debentures, one debenture, one security are moving, how they are moving. So if this is a situation, you understand that if it's one, they move, the absolute positive correlation. If this is -1, absolute negative correlation. So there is a very so this is, implications of this is absolute negative correlation. This is absolute positive correlation. This is from your study notes, wonderfully given. The weights are given as half and one third, and the standard deviation, that is the risk of security A and risk of security B, is given. So what you do is that you calculate the risk of the portfolio. So what is this? This is the risk of the portfolio. Risk of the portfolio comprising of two shares A and B in the ratio of half and one third. So and this is coming, and this is the solution. And very interestingly, if you now consider -1 as your correlation, so that the shares are absolutely negatively correlated with each other, then your risk is minimum. So when your is equal to -1, that means absolute negative correlation, risk is minimum. Why? Because your diversifiable risk is moved away, is gone. And when your is +1, then risk is maximum. That is, you have chosen your shares in a wrong way. You have taken shares which are directly related to each other. If one shares in price increases, the other share price also increases, and therefore they are not related. They are not. You have not done a very good job. So there is a line in the study notes which I picked up, and this says the amount of systematic risk is measured by beta. Of course, you are final year students and you know the connotation of beta, but I still felt like including the connotation of beta, because what happened was that, very simply, Markowitz gave this standard deviation as a measure of risk, and then he showed that risk, the non-systematic portion of the risk can be diversified away. These student William Sharp and Mossin and Linton came up with this concept of beta, which is a relative concept of the non-diversifiable risk. So what is beta? Beta is a relative concept, whereas standard deviation is an absolute concept. It's a relative concept of risk. Of I'll say non-diversifiable risk of the portfolio. So and remember that the beta and of the Sensex is 1. I know that you have all done this, but just a basic concept, interpretation of beta, the capital asset pricing model. Of course, this is and the model, and this question actually came, so I thought of including the cap. Now we come to risk management. Now risk management is nothing but how do we, so we understand the connotation of risk. So how do we go about it? What we do about it? Now, basically speaking, we can avoid it. We just don't think about it, and we can mitigate it, mitigate a portion of it. Our total mitigate total mitigate the total portion of it. You will find this given in the study notes. So management is how you go about it. So financial management is after you understand. So once you have measured your risk, how you go about it. Now there is a very interesting thing I have included. The traditional risk management considers each of them separately, each risk separately. But enterprise risk management, which is also the thing of the syllabus, is when you consider the total risk of the concern. So please look into this. This is a very important issue. And whenever you talk about ERM, you talk about, you have to, there's a question which came, interpret the essence of QRM, summarize the actual need for implementing a ERM. And I have, in my opinion, written something about it. This is one way of issue risk mapping, and this is also a very important framework, because it is how from 2004 onwards we have been started filling about the COSO framework. So this is the COSO framework, and I have, these materials are, some of them are taken from your study notes, some of them are not taken from your study note. Now we have moved from this diagram is also from your study notes, a very interesting diagram. So this is, here we used to have our prior to that, I'll say prior to that, we used to have our traditional this is a traditional risk management was here, and we tried to move into tried to move into our foundational ERM, and then from there we have moved on to the risk enabled ARM. So this question, this is also from the study notes, and you can just look into it and refer to me whenever required. I'll just say a little bit about the last issues which I have covered up, and that is your corporate failures, corporate distress analysis. So corporate failure is a situation where you are gone, and there are various models of corporate distress analysis, prediction failure models, where we mainly talk about the Altman model. And in the Altman model, the Z model, it's very important to consider this Altman model, because questions are regularly coming. So this is important, because questions are regularly coming on the Altman model. So basically there are 5 ratios which we calculate, and the 5 ratios which you calculate, and then you take the scores. If your score is less than 1.8, it is high risk of bankruptcy. 1.8 and 3, zone of caution, red flag. So you can call this red flag. And finally, if it is more than 3, then there is less scope of bankruptcy. Now this is not in your study notes, so this is extra. So be careful about this. This is how your Altman model developed over the years. Now this is covered. This is what we did. There is also the Zeta model which you have to think about. Because of course I have taken till after 2000. After that, there are some models also developed. These are all adaptations of your Altman model. You have the Benish model. It's a very important because you predict fraud. So this is a prediction of fraud. Of course, these are all probabilistic models, and therefore to some extent they're true. And there are 8 issues. Of course, there is another model of the same name, Benish M5 model, but this is more popular. And again, you calculate 8 ratios and take the 8 ratios. And finally, you have, if you're, these are the individual. So the individual manipulators are also given, and this is the final. This is the final. So if the 8 ratios, if the score is less than minus 2.2, then their company is surely frauding. Otherwise, if it's greater than minus 1.22, it's not. And finally, you have the NCR model. You will not find this in any book, but the National Council of Applied Economic Research, long back in 1979, came up with a study, and this is from their work. What I've done is that a question came some years back in the study notes, in the examination, and I have tried to come up with it and solve that for you. So this is this, and I understand that uh, uh, it's it's really very fast that I've been going on talking about these issues. I'm sorry for this, but this is the maximum I could do. And if you are into my classroom, then you will have the study notes immediately after the class is over. Otherwise, you have to look at wait for them uh, right channel, the proper channel. You will get the proper material to the proper channel. And one more thing. There is a grooming session at 1 o'clock today, and that is why my class is truncated by an hour. They requested me to truncate my class, and I have obliged. So please join the class because okay, fine, studies is okay, but you have to also get into proper employment. And as I said, they are going to help you. This institution is a great institution. It's my alma mater, and they are going to give good placements to people. But you have to prove yourself. And now time has come where you prove yourself. You prove that you can do the job. So it is all about employability and whether you have. Okay, fine. A number of people passes examination are very comfortable with the sums, with the numericals. They come up with the solutions. They make everything possible. But regarding interviews and making people, once in an interview, what you have to do is that you have to make the interviewer know that you can do his job. Now, if he's asking for a different kind of job, if he's, for example, if he's looking for a man who can kill somebody, then you tell him that, yes, I can do this job for you. So simple, something like that. Sorry. Uh, but the point is that you are qualified accountants, cost accountants, and now is the time that you prove not only that you know the answers to the sums, but you also show that yes, I am worthy of the thing you are offering. So go do the grooming sessions because this is a very crucial time. Previously, in the inter level or after the inter, you got to your inters. There was a time when you just scored and passed the examination. So that was the only target you had, passing the examinations. Now things are over for you. You are almost at the end of it. So groom yourself, be prepared for the interviews, give your interviews to the best, make them believe in you, have faith in yourself, expand your knowledge. So, this strategic performance management 20A is an interesting portion where, as I said the first day, there is only one book in at least to my knowledge, by Bernard Marr on the name of the book is Strategic Performance Management. Whenever I was searching for books in performance management, I saw books which were talking about performance of the person. So, but your topic of strategic performance management is beautifully designed to cover various issues of your study notes here and the line here and there, and they have covered up everything. They have tried to cover up everything. It is okay. I'm very sorry for this. There was a call from the institute. I am very sorry for this. This is grooming session is for the examination which is coming up. It is not for your placements. There was a clarification from them, and I'm extremely sorry for wrongly stating this. But this grooming session is for the examination which is coming, and therefore it is more important that you attend the grooming session. Sorry for the miscommunication. I thought the grooming session was for your placements. It's not like that. It is for the examination which is coming. Please attend that. It is going to help you regarding that. Maybe the placement things will be coming up after the after you qualify for your uh, qualify the cost accounting examinations. Of course, my number is given, and we can also communicate through the Google Classroom. Thank you very much. Here I end.
Thank you, sir.
Thank you, Bappa. Sorry for miscommunication.
Okay, sir. Okay, sir. Okay, sir.
Okay, okay.